Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Stefan, who has just completed the course Linux Basics. So he'll be giving us a presentation on that. So first of all, we'd like to see him demonstrate that his code base can run on the real robot, as we always do. And then after that, we'll get into the details about his code. Okay, so without any further ado, I'll now hand over the platform to him so he can begin his presentation. Alright, okay. Whenever you're ready, Stefan.
Alright, just give me 1 second to connect to the robot.
Sure.
Okay.
It's taking its time, right?
Yeah. Alright, there you go.
Okay, that's good.
Alright, so let's begin. Hi. Alright, cool.
Alright, so and it starts moving. Okay, that's cool.
Alright, so as I get the robot statistics up and going, I'll explain what it's doing. So the robot is essentially doing a scan. There's 5 lasers that cover 180 degrees. From left all the way to right. And first, what it does is it gets the laser scans and it does an evaluation. It checks to see if there's any obstacles in the way via threshold variable. So there's a threshold variable that I have that's set to 0.3 meters, if I remember right. Yes. And essentially it evaluates that, and if it gets a laser reading that is greater than that threshold, then what it'll do is it'll move forward a few meters. Not even a meter, less than that actually.
Okay.
And let's say for the sake of argument that there is a obstruction either in front of it or roughly in front of it. Then what will happen is the laser will check each side laser. In other words, it will check the left laser and it will check the right laser. And it will do an evaluation. If one laser is greater than is reading a greater distance than the other laser, then what it will do is that the robot will turn in the direction that has the greater laser. It's not showing a obstruction that is as close as the laser that has the lesser reading. And it turns, it essentially waits for delay, and then it will stop, and then it reevaluates again by getting the frontal laser readings again, evaluates, and if there's no obstruction, then it moves forward. And it basically does this in an infinite loop until basically I fill the application.
Okay, so can you tell me something? How do you determine how far it has to go, right? How did in your script, right? How do you determine how far or for how long does the robot move?
Pretty much time. I basically had it set to a specific time of it moving forward. It wasn't that I determined here. I'll actually show it here if I may.
It's okay. Yes.
Uh, you know what? I'll just explain it. Pretty much what I did in the code base is I did this right here. I calculated the time to move by taking the distance to move,
All right.
which is basically a variable evaluation, and I divided it by 0.1 meters per second.
Right. Okay.
And then essentially I basically have a sleep function right here that will essentially, it'll stop it first.
Right.
No, I'm sorry. It will
It
set
was.
it.
Yes. Set that velocity. Yes.
It will set the velocity. It'll put a time delay, which is basically essentially the time to move.
Okay.
It moves it for that amount of time, and then it essentially stops it again.
Okay. You can leave that one open actually. So since we are talking about this right now, so what I would like you to explain to me is what was that again? Hang on one sec. Okay, so there is time to move, and then I wanted to ask about the distance, right? How do you determine the distance? Because you are using distance to move. How do you know the distance it is to move? Yes.
Okay, so right here, this is the frontal laser right here. This variable represents the frontal laser scan.
Correct.
This is the threshold the variable that I was telling you about. So basically, we subtract the threshold from the frontal laser range.
Right.
And essentially whatever's left over is the distance to move.
Okay, correct. Okay, so let's go on.
Okay, so essentially that, I think, let me make sure that I got this right. Robot.
Sorry.
I apologize because I handled this ahead of time and for some reason got bashed. I apologize for that.
No, it's alright. It's alright.
So essentially,
try using tab. It will probably help.
Yeah.
Yeah.
Thank you.
There we go.
Thank you, sir. Okay, so on top of it moving, I was also required to implement this robot statistics script, and essentially, pretty much this prints out all of the odometry information.
All right. So, what parameters are you taking note of when in that script, right? Which odometry parameters are you outputting, or are you taking note of?
Okay, so this script came about as a result of the second part of the project, and pretty much I had to implement literally a bunch of getter functions. Pretty much, I get everything from the odom topic. Pretty much, all of these parameters are snagged from essentially the odom topic to give me the readout of every single thing that I'm printing out on screen.
Okay.
So pretty much I basically call everything, and then in the robot statistics function, in the robot statistics script, I essentially just print it out on screen. I have all of my getter functions here, and then in the script itself, all I'm doing is basically running a while loop that will print everything on screen.
Okay. All right.
In order. So the script itself isn't taking a parameter directly. It's more like the parameters coming right here.
Okay. From your getter functions.
From the active functions.
Right. Okay. All right. So that is just printing them out. Okay. So give me like 3 parameters that your script is actually printing to the screen.
Okay. So we've got. Let me just blow this up.
Sure.
Okay. So we've got the instantaneous angular velocity. X component. That's basically the rotation.
Right.
And we also have, this is out of order, yaw, pitch, and roll, basically how it's rotating on the X, Y, and Z axis. and then also we have the linear acceleration, which is basically if it's moving forward in a straight line, but I print out the individual x, y, and z components.
Right. Okay. All right. I see. Okay. All
And
right. I think you wanted to say something. Go ahead.
no, I just mentioned the distance itself as well, and also the direction of that it's heading in. This n indicates north, moving north.
Okay. All right. That's cool. So, did you have any instances where the robot crashed during the development of your obstacle avoidance script?
Believe it or not, it didn't crash. What ended up happening was when I ran it in the simulation, everything was fine. I basically let it run for about maybe 5 or 10 minutes,
Mm-hmm.
and then I ran it in the actual real robot lab like it is now,
Mm-hmm.
and there was essentially a instance where I don't know if you can see my mouse, but it
Yes,
got right here
we can see it. Yes.
and essentially just stopped. I checked my command line and everything seemed fine. It just stopped. It didn't want to move or anything. Everything kept printing as usual and it stopped. And so what I did was I figured out that the if statements that basically checked the laser conditions,
Yes.
they were incorrect. They were wrong. And essentially what I did was I made some corrections and basically ran it again under the real lab conditions, and it worked. Thankfully, it worked.
All
Nothing
right.
happened there.
All right. Can you get into the details about what it is that was wrong exactly? That's what we want to know,
Yes.
right? Yes.
Yeah. Okay, so let's take a look. Back. There it is. Okay, so here's the conditions right here. The 8 conditions to test the frontal lasers. Pretty much it was this part. Not all of the test conditions were wrong, but there was instances where I had this right here.
Oh, okay. Okay.
And pretty much the robot wasn't reading that condition, therefore it didn't know what to do. It just stopped. It didn't do anything.
Uh-huh.
Pretty much, I think if I remember right, it was this that was slightly wrong, and this case that was slightly wrong. And that's literally the reason why I kept the pseudocode comments in place, because you guys wrote really good pseudocode that helped me figure out what I needed to write.
Mm-hmm.
And pretty much I kept them on there. And when I looked at the pseudocode and then I looked at what I actually did, I go, okay, yeah, this is wrong. This is incorrect.
Okay.
And once I fixed that issue, then I ran it again, like I said, and it ran perfectly. The other issue that I ran into is that this is a weird quirk when it came to Linux. Apparently, it's space sensitive. So when I wrote these if statements,
Yes.
I had everything just, I guess you could say, smushed together without any spaces. I mean,
True.
you could
Yes.
still read it, but right here, there was no spaces here.
Mm-hmm.
There was no space here, and I tried running it, and I'm like, okay, I think this is 100% right.
Yes.
And then I'll admit this, that I had to actually Google this.
It.
But it's space sensitive, and so I made the space, and it actually worked.
Yeah. It's alright. It's part of learning, right? As long as you do understand why you had to do what you did, right? That's the whole point of having to do something to learn about a particular concept, right? All right. So, can you tell me something about floating point numbers? What did you learn with regards to the processing of floating point numbers in Bash scripts?
Okay, so with floating point numbers, one of the things that I actually had difficulty in is truncation. If you accidentally read the floating point number as an integer, it will actually truncate
The decimal point, like what's after the
decimal point,
right? What's after the decimal point?
which is actually an issue that I was running into when I was doing readings. I basically had to read it as a floating point value rather as an integer value. In fact, in some of the other courses that I'm working on, specifically the C++, that has actually gotten me into trouble where I'm reading things accidentally as an integer value
Mm-hmm.
when it should be a floating point value.
It's,
That was one issue that I had to get over.
So how did you deal with it here? In this Linux for robotics basics?
It wasn't that bad. Pretty much, there wasn't that much I had to do other than, if you can read this here, since I knew that special little quirk about floating point values,
Mm-hmm.
when I was evaluating the information right here, I actually used that to my advantage. This right here, if you notice, it's reading 0, but it could be a higher decimal value.
Okay. All right. All
And
right.
that decimal value can basically be wiped away because we only need it. We only need to check if the laser is actually reading that string, not necessarily what the minute decimal value is.
Mm-hmm.
We don't need it for that. That's basically how I handled it in this script.
Mm-hmm.
Basically, knowing that, okay, if I don't need those extra floating point values, then I can just truncate it and just cut it off at 0, and everything will be okay.
Mm-hmm. Okay. All right. All right. So I think what we gotta do now is maybe let's have your code run in simulation just for good measure, right? But we have seen that it's
Okay.
working correctly on the real robot. So
Okay.
okay.
Let me just cut this off real quick.
Mm-hmm. I think you should disconnect so that you can run your
Yeah.
simulation. Yep.
There we go. There it is. When I was testing out the getter functions,
Mm-hmm.
I did it within this simulation, and the funny thing about it was, when I tested, I think more than 3 functions, for whatever the reason is that it would crash it.
Okay. All right.
That's the weird quirk.
So it crashed as if there was some form of overload. Did you consider what did you think about it? Did you think it was some type of your machine or the virtual machine getting overloaded?
I think, honestly, for me, probably more so my machine, because I'll be honest with you, I've got a little laptop that isn't the strongest in the world.
Uh,
So maybe it's a combination of my machine, and on top of maybe just asking for too many functions.
okay, it's an interesting thing to note, but I'll try to look out for that myself to just see when does that really happen, and yeah. So that was in the simulation, not when you're running it on the
Not
real.
in the, yeah, in the simulation, yeah, that's it. Pretty much was happening on that,
Okay.
and I'm like, okay, this is kind of a weird quirk, but the good thing is that I was able to actually test those getters to actually see if, okay, am I actually getting the value back?
Okay. All right. So that was a good validation point. Okay. All right. There we go.
See if I can blow this up.
Mm-hmm.
Give it a second. It takes a while with this little version.
Yeah.
There it is.
Mm-hmm. Okay.
for sure it's definitely my machine.
You think so?
Even though even though I'm not directly running the Zibo on my machine, I can tell you that my machine probably isn't strong enough to fully run it.
Okay, all right, so good. At least we see that it's working and it's responding to um, your program.
Right? And I'll run the robot statistics right
Okay,
here.
all right.
Um, here we go.
Okay, all right. Yeah, even the values are coming slightly slower as well. So
Yeah. I think it's more so because of me rather than you guys.
yeah,
You
it's
guys
all
have
right.
probably better hardware than me.
No worries. Okay, so I think this is good enough. It's a wonderful presentation, and thank you for showing us exactly what you did, why you did what you had to do. So I'm just going to ask you some very general Linux questions, right? So um, there are some tools that we do consider you to know just by having done this course, right? So can you explain to me one of the major commands that you can use to get output about the load that your machine is experiencing in the command line, right?
You mean like are you talking about just general output
Um,
like for example
like
like
CPU load, for example, right? Or process IDs and how much CPU power they're using, for example. So like what you do if you want to do if you're using, for example, GNOME, or if you're on a Windows machine, you would have like a task manager, right? That will show you all that detail. What is the alternative for that in the Linux terminal? Yes. Yep. Wonderful. I like the way that you had to demonstrate it, right? So you had to demonstrate. This is the benefit of having to practice it, right? Because when you do practice it, sometimes you have some latent memory that you probably cannot say it off the top of your head, but it's inherent, right? It's like muscle memory or something like that. Yeah.
like I'll be honest, I was this close to saying I forgot.
You could, I think, also do PS Fox if I'm correct. You can try that, and then yeah.
There you go.
Yep, you can also have that detail there, right? All right, wonderful. I think that was my only question with regards to like the general of Linux, but I'm very glad your base scripts are working. You've shown us how you implemented them, and also highlighted some of the nuances that you experience, because we think it's more in the nuances, right? That's where you get the details of different types of programming languages. So thank you very much for that, and it's been a wonderful presentation. So you just hang around and we wrap it up here, okay?
Alrighty, thank you, sir.
All right, it's a pleasure. Alright everyone, this was Stefan's presentation, and a very warm congratulations to him, and would like to encourage all those of you who would like to come and showcase your work. So once you've done the course that we offer certification on and you want to come and present, it will be very beneficial to you as well. So